Hey guys, I wanted to share a solution that I think is pretty neat for a problem that I was having in a project that I've been recently working on, and that project is a Discord bot. And in this Discord bot project, I have this issue where I'm doing work in sort of a multi-threaded way, with even some of that work being done in the background away from the main thread, and so but all my threads are accessing shared pieces of state that live on this class. And so I have this issue where, or I have this potential issue where there can be race conditions where one thread's trying to write to something and one thread's trying to read from something, and so we have this potential for race conditions. And race conditions are terrible because they're always hard to figure out what's going on. It only happens every so often, and when it does happen, you're left confused. And so I think it's a good practice to be thinking about that and thinking about, okay, is this a multi-threaded situation, and is this a shared piece of state, and is there a potential for that to occur? And in my case there was. And traditionally in C Sharp, the way you go about doing synchronization across threads like this is you would use something like the lock keyword. But the lock keyword doesn't work in asynchronous methods or asynchronous code. Instead, you have to use something else. And I want to show you kind of an example of how you would do that, and also kind of a contrived example of where you might use it. So in my example that I've come up with to illustrate this problem, what I'm doing is I'm going to load some products from a CSV, and then I'm going to spin up 3 different tasks, and each task is essentially going to import these products into my database. But before we import a product, we're always going to make sure, does that product already exist by name? And if the product does already exist by name, then we're not going to add the product. The problem here is this has the potential for a race condition because each task I spin up is going to run concurrently. So we have the chance for multiple threads to be trying to check if products exist and then insert products. And so when one thread checks, the product may not exist, but between that thread checking and it going to insert another product, another thread has already done the insertion, right? So you have these race conditions. And granted, I know you're probably thinking, well, Steven, this code is terrible, and there's like a half a dozen other ways you could go about solving this problem. Yes, that's the point of the code. This point of the code is just to drive home in a very clear way this idea of race conditions in asynchronous code. And so in this case, what I need to do is I need to protect this critical section of code with something like a lock, right? And so the thing I've seen people do the most in the C# world is they'll use something called a semaphore, and particularly a SemaphoreSlim. I know .NET has a few different, or C# has a few different constructs that are supposed to facilitate this ability to do kind of synchronization across threads. And there's obviously other approaches to this, but in this case, in the majority of cases, I've seen people use a semaphore. And so the way you new up a semaphore is you say, okay, when I new up the semaphore, I essentially want to declare what's the initial count, right? So what's basically the initial number of threads that can be accessing this critical section of code, and then what's the max number of threads. And so in this case, I'm going to say, well, 1 to begin with, and then a max of 1 as well. And then once I have that semaphore, I can go down and use it to protect this critical block of code. So let's go ahead and take this block of code, and we're going to stick this inside of a try block here. And then we don't really have need for a catch right now, so we'll just add our finally block. And then what we're going to do is, before we enter this try statement, we need to acquire the lock, right? So we need to wait on the semaphore. So if there's any other threads that are trying to access this block of code or this section of code, we need to wait for that to finish before we can enter this block of code. And then once we've done our work, we need to release the semaphore so that whoever else might be waiting can do what they need to do. So we'll go ahead and release it down here. And so now with this in place, we can avoid the race condition. And I just realized I didn't actually show you the race condition happening. So let me show you that real quick before I put all that into place. So let's delete this. And so before I use the semaphore, you'll see if I run this program, I'm supposed to load 17 products, but you'll see sometimes I load 17 products and I insert 17 products, but sometimes I load 17 products and I insert 18 products. Or sometimes I'll insert 19 products. It just depends because, again, this is a race condition. Here in this case, we did 20 products. So this is that race condition behavior happening. And so now what we should be able to do is we should be able to put back all that code I just wrote. And it's yelling at me because I'm not using the return value here, so let's just discard that. Now if I rerun my code a couple more times, now we're going to get deterministic consistent behavior. 17, if we run it again, we should get 17. If we run it again, we get 17, right? But from a developer experience, this is kind of verbose, right? So imagine you have multiple cases where you need to do synchronization like this. And so every block of code that you need to access is going to have to be wrapped in this sort of statement where you get the semaphore, then you try to do your work, and then finally you release it, right? Which could get, I don't know, painful to write that over and over again. And so the way I came up with making my life a little bit easier, making this a little bit more convenient to deal with, is I actually went ahead and just implemented an asynchronous lock class. Basically using the same primitive. I'm still using the SemaphoreSlim, but what I'm doing is instead, I'm now going to create an asynchronous lock instance. I'm going to have one method on that asynchronous lock, and when I call lock async, we're going to wait for that semaphore. And then we're going to return a new instance of what I'm calling a releaser, which is basically just a class that implements IDisposable. And so whenever this releaser is disposed of and cleaned up, we are going to release that lock, right? And so this way I can now have a very similar experience to what I would normally have with the lock keyword, but I can do it in an asynchronous way, in an asynchronous context, by using the async lock class and a releaser and the IDisposable interface. So IDisposable just means, hey, you got to have a dispose method, and then what we can do is we can use the using keyword to basically declare our scope, and then whenever the variable that we've declared or the lock we've declared actually goes out of scope, we can rely on the GC to clean it up and run the disposal and free up the resources, or in this case, free up the lock. So what does this look like if we were to actually use it? Well, now what we can do is instead of creating a semaphore, is we can create an async lock, which is that class I implemented. And I'm going to call this at lock, and I'll just new that up. And now I can come down here, and instead of having this await semaphore and the try finally block, I can just come over here, delete all that. And then I can do this one of two ways. I could do using await at lock.lock async, like this. And then I can define my scope very explicitly, like I would with the lock keyword. Let me get out of that line. All right. And so now we have the same effect where first we're going to acquire the lock, and this lock async method returns an IDisposable object that when disposed will then free the lock. So whenever I get out of this scope, we're going to let go of that lock after we've acquired it. So if we rerun our code, we're going to have the same effect. No more race conditions. Every time we run this, we're going to read 17 products in from our CSV file, and we're going to insert 17 into the database. The other way you could do this, if you didn't want to be as explicit with the scope, is you could just use a discard. So you could say using var underscore equals await lock async, and now it's sort of inferred, right? We'll make this explicit. Oh, we don't have a releaser because it's not public, so we'll just do var. And so now what we can do is we can do the same thing. Every time we run our code, we're going to get 17 in, 17 out, 17 in, 17 out, consistently. But this is much more succinct, right? And much more reusable. So now basically anywhere in my code base where I need to do some sort of synchronization in an asynchronous context, I can just grab an instance of the asynchronous lock class, call lock async, make sure I use the using keyword, do that, do the work I need to do that's potentially could have a race condition involved, and then move on. So I thought this was kind of clever. I think it's an interesting use of the IDisposable interface. I don't see people leveraging that as much. Obviously, you don't necessarily have to use the using. You could also very explicitly do R and then say r.dispose, right? That's going to do the same thing. This would be equivalent to like freeing the lock. But this is, again, it's like you've got to remember to do it. You've got to remember to call disposed. Instead, we can just use that using keyword. And we can do using var, and then we can just discard it since we're not using it. So I thought that was useful. Like I said, if you have a similar situation come up where you think, okay, I've got some multi-threading happening here, I've got shared state, I need to do some synchronization, but I don't want to have to always write await semaphore, wait async, and then try, and finally, let me just package that all up into a nice reusable implementation that makes it much more pleasing, I should say, to write and use. This is how you could do it. So I hope you guys thought this was helpful. If you did, leave a comment or find me over on Bluesky. Otherwise, I hope you guys are having a good day, and I'll talk to you guys later. Bye, y'all.